Now we're going to play the Can I Beat My Phone Battery game. All right, hopefully this is the last video, but we'll see. All right, so next term we need to, come on and focus, define here is a recursive sequence. So that means each term in the sequence is defined by a previous term in the sequence. So sometimes we will ask you specifically for a recursive formula. So a great example of this are the Fibonacci numbers, which are 1, 2, 3, 4, 5, 8, etc., etc. Fibonacci sequence. So just to show you how this works, we call this one a sub 0, a sub 1, a sub 2, a sub 3, a sub 4, etc. So you'd have to show, and it's with the givens, that a sub 0 is 1 and a sub 1 is also 1. Well, for those of us who have never seen Fibonacci before, how did we get 2? Well, you added 1 plus 1 to get 2. How'd you get 3? 1 plus 2 is 3. How do you get 5? 2 plus 3 is 5. How do you get 8? 3 plus 5 is 8. So really what's going on, to get the next term, you're adding the previous two terms. So you'd provide your given, and you'd show that, oh, hey, yeah, a sub 2, that's really, again, you're always taking n minus 2 plus a sub n minus 1. I'm really adding the 0th and the first term. 1 plus 1 gives me 2, which was a sub 2. For the third term, you were adding together the a sub 1 and a sub 2, which is 1 plus 2, to get 3. This was just an example. It wasn't anything to actually work through, just to show you a famous one. Okay. Sorry, that was kind of not the best transition, but here we go. All right. So summation notation is the sum of terms for a finite sequence, sigma notation. So here's your sigma. And this is how we write it. You have your sigma, you have I equals 1 to n. I is called the index. N is the upper limit, meaning what are you going to go up to? What are you going to stop at? And 1 in this case is the lower limit, meaning what are you going to start at? This says a sub I. So this is saying I'm taking a sub 1 because it's starting at 1 plus a sub 2, a sub 3, all the way up to whatever a sub n is. And I'm going to add. So sigma, again, means to add up your a sub I terms. Okay, so for number 5, if it said find each sum, you have your lower limit of 1 and your upper limit is 4, and you're doing 3i plus 1. Okay, so for when I substitute 1 into there, that's going to give me 4. So again, that's my first term. And I'm going all the way up, so second, third, and fourth. I'm just kind of doing that for a visual for people. So my second term, I'm putting 2 in here. That's going to be 6 plus 1, which is 7. Then I'm putting 3 in here, 9 plus 1, which is 10. And then my last one, 3 times 4 is 12, plus 1 is 13. So you're going to add all those together. Your answer is 34. So that couldn't be blurry. That would be just lovely, but you know. Okay. For part B, your lower limit is 1, your upper is 5. You're doing quantity negative 1 to the I minus 1 times I factorial. So we're doing 1, 2, 3, 4, 5. All right, so when you put 1 in there, we're going to have negative 1 to the 0 times 1 factorial. So that's going to give us 1. The second term, that's going to be negative 1 to the first, which is going to be negative 1, times 2 factorial, which is going to be negative 1. Maybe people want me to do it at work. Negative 1 times 2. 2 factorial is 2, so it's going to be negative 2. My third term is going to be negative 1 to the second times 3 factorial, and 3 factorial is going to be 6 times a positive 1, so that's 6. This is the fourth term is negative 1 to the power of 3 times 4 factorial. 4 factorial is 24 times 8. This is a negative 1, so that's negative 24. The fifth term will be negative 1 to the fourth, which will be positive 1, times 5 factorial. 5 factorial is 120 times 1, which is 120. You're going to add that all together, and your answer is 101. All right, so properties of these summations. If your lower limit is 1 and your upper is n, and you have c times some a sub I. C is a constant, so there are proofs for this. I was going to spare you from watching them. You got enough on your plate right now. Just let's try to understand this. I showed you one proof. I can show them if you would like. Contact me if you want me to do any of them out. But so you can basically take that constant on the outside, multiply that by the summation of just a sub I, and those are the same thing. The second property is if you're adding together or subtracting an a sub I and a b sub I, you can just take the summation of each of those two and add or subtract them together. If you're taking the summation of just some c, where c is a constant, you're just really doing c times n, how many terms there are there. So those are the properties. All right, I'm going to pause or stop and do the last video because I'm running out of battery.